All right, so continuing on through chapter 9. Before we do that, though, we're going to start with the kickoff here. So, regular pentagon, P-E-N-T-A. Now, drew a little bit better than my last lesson. Still not a great pentagon, but it'll work. So, again, if we think back to 360 is all the way around. So if there's 1, 2, 3, 4, 5 points on a pentagon, we would take 360 divided by 5, and that would be 72 degrees for what the angle is between each of these points. So remember, rotation, we're going counterclockwise. So if we're going to start at E, 72 rotation would just be 1 point back counterclockwise here to P. And if we're going to go 216 degrees from P, we would go 72, 144, 216 would be 3 different points, which is N. So remember, we had rotation where we could take a shape, we could rotate it about a point and move it over. Remember, positive is counterclockwise, negative is clockwise. But yeah, that's what was going on last time. Now, here we're going to go a little bit different, so we no longer have those isometries. There's only 3 isometries where you get the exact same shape, and that was the translation where we slid it, the flip, which was reflection, and then rotation where we take it and we turn it. Now we're going to start into other stuff, starting with symmetry. So we're still involving isometries. It's just not exactly a congruent shape, but instead it's going to deal with symmetry itself. So symmetry would mean where we can cut something in half, fold it over, and match back up. So both sides then are perfectly the same. Not necessarily in shape, but compared to the other side, it's a mirror image. Think of it that way. So again, we could take it, we could flip it over. So think it's reflectional symmetry or line symmetry here, where we have one line and we could take this half of the mass, fold over, and it'd fit on that one. So it'd be a mirror image of itself. Now, if we think about a regular hexagon, so a hexagon has 6 sides. So 1, 2, 3, 4, 5, 6. So we have our 6 points here of our hexagon. So really we can split this down each way, down the middle this way, or down the middle this way, and it would match up. Now we could do that with each set of sides and each set of these angles cutting through. So it gets to be a jumbled mess because there's a lot of things going on here, but think every time we can split them in half this way or we can split them in half that way. And we'd be able to take that shape, fold it across that line, and it would match up with the other side. The other part of this is rotational symmetry. So rotational symmetry is if we have a specific point and we could rotate it around either 180 degrees or less, meaning we couldn't take this and rotate it all the way around at 360 and match back up because you're the same image. It hasn't done anything if you go all the way around. So we're 180, we could take it, we're flipping it halfway and it matches back up, or anything less than that where it'd match up. So a figure that has point symmetry is when it's exactly 180. So if we can take it, flip it at 180 degrees, that's called point symmetry. So this is what I'm talking about. So like a square has 90 and 180 degree rotational symmetry with the center of a square. So if you think about it, if we make a square here, so we could cut it that way or this way. So rotate it 90, so it would go from, say, this one to this one, and it would work. Or we could go a full 180 and take this bottom and move it to the top and make that fit back up again. So square being all sides the same, all angles the same as well. We could take that, turn it 90 and match up, or take it and do a half turn and it would match up. So that's what we're talking about with rotational symmetry. Same thing here with the triangle. We could take this point, rotate it around to that point, and it would match back up again. So take it and spin it, and it would look like the same triangle. We could spin it some more, and it would look like the same triangle. So in this case, there'd be 3 different spins we could do with it to have rotational symmetry. Now, our angle of rotation, you're just going to find that by how many times it would take to rotate around, and then divide that into 360. So 360 In this case, we had 1, 2, 3 rotations. So we divide that by 3. So this one's angle of rotation would be 120 degrees. So it'd rotate 120 degrees before it'd match up again. And then we could do another 120 and match up, and another 120 and we'd be back to where we started. Now, this one over here, it's a little bit odd shaped so that if we rotate it, so there with the flat on top, if I go to the next flat, yeah, that doesn't look like the same shape. If I go to the next flat, again, not the same shape. So it has to be able to rotate around and be the exact same shape. So here there would not be rotational symmetry. Okay. So has to be able to rotate around less than 180 and match back up with itself. Now, there are three-dimensional objects that could have some rotational symmetry. It could also have reflectional symmetry. So like here, we could take this and cut it that way and be able to fold this over each other and it would match back up. Now, from there, we could have rotational symmetry, flipping it down and around. So take the paddle, flip it right back over, and it would have rotational symmetry. So it could have both rotational or reflectional symmetry on this one here. Now, this cup gets harder because really with this handle here, that really messes up. We would have had an infinite amount of times before the handle, but with the handle, we could only rotate around all the way around, so it would not have rotational symmetry. However, if we had, say, a flat plane that's cutting through here, you know, it would cut through, say, where this handle is. We could split that handle in half and be able to fold or take it apart, and both sides would be the exact same. So it could have reflectional, but it wouldn't have rotational. Because again, rotation, we'd have to rotate all the way around to make the handle fit. You know, it has to be 180 or less to have rotational. Reflectional, we could take this and cut this in half where we're going right down that handle, splitting that handle in half, cutting across, and then each side would match up. So that's it for this lesson. Let me know if you have any comments, concerns, any questions. Otherwise, until next time, we'll talk to you later.